Welcome to our first video from Chapter 2, Section 2. It's on power functions. Before we get into what a power function really is, I just want to review some algebra stuff with you. What we're going to do in this first set of problems is take this initial idea that is a variable raised to some sort of a power and just rewrite it so that we have just nice positive integers as our powers, and then maybe using things like square roots or cube roots or fourth roots to finish things up. So for our first example, we have x to the 5/3, and we are allowed to rewrite it like this. We're probably more familiar with starting with this idea, a power raised to a power, multiplying them together, and getting this. We're just doing that process in reverse right now. Okay, and then x to the 1/3, a 1/3 power really just means a cube root. So that is one way to write this, where you would say, let's take the cube root of x, and then whatever answer we get there, let's raise it to the 5th power. But we are allowed to take that first step and reverse the powers. And if I did that, then that x to the 5th is inside the cube root. So that's just kind of interesting. These things are really equivalent, and you can pick which one you want to use depending on the type of problem that you're dealing with. Sometimes one version is a little easier to work with. Okay, for part B, r to the -3 power. The trick there is to remember that as you switch these sorts of things from a numerator to denominator or denominator to numerator, the sign of that power changes. So this would be the best answer according to our instructions. And then in part C, m to the 1.5 power, it might be helpful to initially write that as a power of 3/2, more of a fraction. And then if we think back to what we saw in part A, I could split that up, and maybe the denominator of 2 is going to mean a square root, so maybe I choose to keep the power of 3 right by the m and have a square root over everything. Or I could write it like this, where I take the square root of m and have the power of 3 on the outside. Either version is technically correct. For the second set of problems here, what we're trying to do is take the given idea and rewrite it where we have a coefficient out front, and then we're going to multiply times a base of x and some sort of power. And we just want a single number for that power. And so that's some complicated instructions. I think if we just go through the examples and eventually we get to that final answer, you'll kind of see what the intent is here. One nice thing with part A, when we are multiplying different chunks here, we can take individual square roots. That works out well because square root of 16 is 4. And then just like we saw in some of our previous examples, that square root for the second chunk, I can just rewrite it as a power of 1/2. And now when we have a power raised to a power, I can just multiply those out like so. We're really close now to having it in this form. I would probably be okay with this kind of an answer, but they do say write it as that power as a single rational number, so we would take that and just write it as a 1.5 power. So it's 4 times x to the 1.5 power. Okay, in part B, same sort of idea, except now it's just with division. So I'm allowed to take individual cube roots of the numerator and denominator. The cube root of 27 is 3, and cube root of x we can just rewrite as x to the 1/3 power. We're really close to having it in this form. Probably the only thing I would do here is just, instead of dividing by 3, let's multiply by 1/3 out front. And so this is a pretty good answer for our set of instructions. So we're just going to stop there, just a quick intro video reviewing some algebra terms.